Welcome to Raise the Line with Osmosis from Elsevier, seeking solutions with leading experts on how to increase healthcare capacity so people can get the care they need during the pandemic and beyond.
Believe it or not, what you're listening to there is a musical representation of the genetics of the coronavirus. And we're going to be talking to three people today who are actually all involved in creating music based on DNA, and they're doing it to raise awareness for rare diseases. It's really kind of an intersection of the arts, sciences, and rare diseases, and we have really just a fascinating half hour ahead of us. Let me first tell you who's with us on the panel. Dr. Aditi Kantipuly is a physician and advocate with a broad-based experience in government, academic medicine, and journalism. Her current work focuses on using the arts to drive health equity in the rare disease space. She's also a Fulbright scholar and author of a book about rare diseases for children called The Zebra Alphabet. She's also a Health Equity Fellow with the Rare Disease Diversity Coalition, which is the first nonprofit in North America dedicated to serving communities of color diagnosed with rare diseases. The gentleman who created that piece of music we just heard is also with us. Stephen Andrew Taylor is a professor of music at the University of Illinois Urbana-Champaign who composes music that explores boundaries between art and science. As a theorist, he writes and lectures on African music, data sonification, Bjork, and Radiohead. In popular music, he has collaborated on concerts and albums with the band Pink Martini, among others, and his music has won awards from the likes of the Guggenheim Foundation and the American Academy of Arts and Letters. Among his commissions are works for the Spoleto Festival and the Chicago Symphony. And we're also joined by Casey McPherson. He's a singer and songwriter based in Austin, Texas, where he lives with his two daughters, Weston and Rose. In response to learning in 2018 that Rose had an ultra-rare neurodevelopmental condition, he founded the To Cure a Rose Foundation and co-founded Everlum Bio, a rare disease lab designed to provide a range of services for ultra-rare disease patients seeking to discover treatments. He's also an advocate of the Sound Health Connection, which is about using music to engage the brain to improve communication and motor function in children with rare neurological conditions like Rose. So thank you all so much for being with us today. And let's start with you, Dr. Kantipuly. You are kind of the ringleader of this. Can you kind of give us a grounding, an idea of what you are doing to use the arts to drive health equity in rare diseases, and then just give us a sense of what's happening with the three of you in terms of a collaboration?
Yeah, so initially how I got started with the arts was my time in India when I was studying rare genetic conditions. And I had met a boy, Nihal, and he was 15 years old and he had progeria. And so progeria is an accelerated aging condition. And at any given time, there is only about 400 people in this world with progeria. And so when I met him initially, I was, we were talking about hobbies and things he likes. And then I just kind of asked him, like, oh, what's your favorite subject in school? And he had told me that, I stopped going to school years ago because I was getting bullied. And, like, what do you really even kind of say to that? Because we all think that education is like a birthright. So it kind of like hit me with a ton of bricks. And so I was like, wow, we really need to change maybe the cultural perspective on the stigma and the isolation and, how to treat our peers who have differences. And that's when the book started, the children's book of the Zebra Alphabet and teaching kids about these rare genetic conditions. I kind of shifted into arts a couple years ago. And then this year, particularly, or last year, really, I was listening to a lot of music, putting together playlists, and I came across Stephen's work, who was just brilliant, putting these genetic sequences together. And I was like, wow, this is like so cool. It blew my mind. And I reached out to him with this idea. I was like, oh, can we make a song for, rare genetic conditions? And 2023, like as Osmosis has announced, Year of the Zebra, and, big things happening for the rare community. And he graciously accepted, and we were kind of putting this together. And then kind of when the track is sort of nearing its end, I was like, what about doing a concert and trying to sort of showcase this as, an advocacy awareness thing. And I was asking in the community again, like colleagues, and someone had recommended Casey. And so Casey came aboard, and he also shared the same philosophy of, raising awareness. And turns out he also had made a song based on his daughter's sequence genetic mutation. And so we were like, oh, that's really cool, because this is exactly what we were trying to do. And so there was a lot of mutual resonance here, and here we are.
Yeah, just amazing. So, Steve, let me go to you. You get this contact from Aditi, and tell us what happens after that. And did you have any interest before or awareness before of the idea of trying to create music from DNA?
Yeah, so I've been interested in science as a driver of music for a long time. And specifically with genetics, so I have two kids. They're both grown up now. But our firstborn son had Tourette syndrome, which got diagnosed when he was probably 7 or so. And our daughter was born with an extra thumb. They got surgically removed, when she was an infant. But I just started thinking that something happened with the recipe, and that's when I really started looking into genetic sequences as a basis for what we could either call data sonification or data-driven music. So I was just kind of plugging along, trying this out in various ways, things like the coronavirus, or one of my pieces is based on this language gene called FOXP2. There's a bunch of other ones. Anyway, sort of out of nowhere, Aditi sort of emails me. And things start happening because Aditi seems like the kind of person that makes things happen. I guess I'll leave it there for now.
I get that same sense, actually. But just to help our audience and to help myself understand, how is it you assign a sound to any particular piece of DNA?
Yeah, that's we call that mapping. So DNA consists of 4 letters, A, T, C, and G, and you can map those to anything. I mean, there's even an article in the satirical newspaper The Onion, which says that scientists succeed in pronouncing the human genome for the first time. And turning it into musical instruments is not that different from just saying the names A, C, T, and G over and over a whole bunch of times. So I did try lots of different kinds of mappings, and lots of failures, and then I finally started coming up with a few that I thought sounded a little better. But besides doing the letters, of course, you can do things like amino acids, and there's about 20 amino acids, and those can be represented with different pitches or different rhythms, and so on and so forth. I kind of like to say data-driven music instead of data sonification, because if you really want to make it sound musical, then you're using the data, but it's not meant to be, a graph. Sometimes I do things which are meant to just really have a kind of scientific meaning, but then that's meaningless unless you have a kind of legend or a caption that tells you what the sounds are representing, if that makes sense.
And actually, let's just listen to a little bit of a sample you sent me. This is coronavirus 6VLN. So, Steve, fascinating. Tell us what we are hearing there.
So that's a small sequence of a protein from the coronavirus. It's using amino acids assigned to different pitches, and the lower the pitch is, the more hydrophobic it is, which means it is afraid of water, and it's going to kind of be on the inside of the protein. And if it's a higher pitch, it's hydrophilic. It likes to be on the outside, facing out into the watery cell environment. Then there's also a few other things. There's a kind of ratcheting sound, and if that's happening, that means we're in a beta strand, which is a kind of way that the protein can fold. And if there's a little triangle sounding, that's a alpha helix, which is another way that the protein can fold. And so if you know these things, kind of like a caption for a chart, you can listen to it and get a pretty good idea of what the protein structure is.
Unbelievable. So, Casey McPherson, let's go to you. I'm trying to figure out here, you have Steve Taylor in Chicago, you're down in Austin. You both have this idea of turning DNA into music. So tell us how you came onto this path.
Yeah, certainly. So, I've been a professional musician most of my life. And when my daughter was diagnosed with her rare genetic disease, that launched me into a completely different environment of creating a therapeutic for her. And so, consequently, I'm having to learn genetics, I'm having to learn drug development, but I'm a artist at heart. And so I have used music as a big fundraising tool, right, to try to help fund this drug development for Rose and these other kiddos. And Rose's disease in particular is a point mutation, which just means one letter was off. And so instead of that gene producing an arginine amino acid, it's producing a tryptophan. And so, I got approached by Columbus Children's Foundation, as well as the Tremere Foundation, and we started talking about raising awareness for these kids, because really none of these children will ever get genetic treatments with our current sort of healthcare pharma model. And being is that I don't have an MBA, but I have played a few shows in my time and written a few songs, thought that, well, maybe a way to tell the story is through music. And so we took some white papers from some, brilliant scientists, I'm sure some that Stephen has read as well, around how you do it. And from my perspective, being a pop artist, I was looking for patterns, I was looking for motifs. And so I took my daughter's healthy allele, girl has 2 X chromosomes, so she's got one good gene and one bad one. And so her healthy allele, that I was actually looking at the amino acids. And so what is that, the pattern that arginine can give, and what's the pattern that tryptophan amino acids can give, and created melodies from both of those. And the way I did that too was just pretty simply looking at those 4 letters, but assigning the T. Like if you're in the key of C, the T is the only one that sort of doesn't fall into that. So I assigned T to a flat third, and then going off of that, just played those amino acids out as motifs. So the verse has the mutation motif, and then the chorus has the healthy gene motif. And so, recorded that song to sort of help, and very interested in this in a way to get people emotionally involved in the story of these children. And this really, I see it as even just a human rights, civil rights issue, because we have the technology to cure many of these diseases. We just don't have the structures and pipelines and models to do it at scale. So, music is a huge way of infiltrating our society and helping us think and be inspired to think differently.
So, Casey, let's listen to a little bit of what we were just describing to us.
I know your words have lost their sound. The single point has cut you down. When you're feeling like there's no way out, hold on, I'm coming.
I guess I want to know what your reaction was when it was all done, and did it capture what you had in mind, and what kind of reactions are you getting from other people when they listen to it?
Well, I ended up having a couple of biotech people actually play on the track. Alan from the Tremere Foundation played some guitar. And so the process of it was bonding, which I thought was very cool, which I've experienced with Aditi and Stephen as well. And what I hope happens is that we have a platform to tell the stories of these children, these patients, on a lens that doesn't look like, nobody wants to hear about a sick person. Nobody wants to see someone that's dying, someone that's in pain. Our social media, we tend to like to show the highlights of good things that are happening. So it's been a big challenge with rare diseases to get it, even with the word rare. We're 400 million people, 200 million children. That's not rare. My hope is that these songs can really make an impact in a larger conversation.
So, Aditi, back to you. What is your hope here? I mean, you've got all of these great elements here. You're sort of the conductor of this symphony, if you will. How is this all going to come together?
I think what we've discussed so far is we're going to try to showcase some of the tracks that Casey and Steven have composed and sort of put it together. But also, another idea was to bring other musicians on board that may have had health conditions and to talk about their personal struggle as well, to sort of advocate for health, lessen the stigma. And I think in the long term, I think what I'm seeing is that it's not just like a one and done concert to bring in funds, like a one time thing. Like I want it to be sustainable. And I mean, yes, we are raising awareness for these rare conditions, but I think it's also a really cool gateway. When we talk about health, there's different aspects. There's physical health, emotional health, mental health, and now I think we're going to see the trickling of genetic health, because sometimes that's like even a black box when we're talking about genetics. So opening those conversations up through music, I think would be a really powerful way to sort of be more active about our own health and well-being.
What would you add to that, Steve?
Everything Aditi said, and the one thing that Casey actually just said really hit home for me is I've been trying to work on this project of turning these genetic sequences of rare diseases into music. The music comes out very sad, and just like Casey said, nobody wants to see a sick person, and I think that if we can find a way to make it uplifting at the same time as a kind of artistic expression, I think that would be my dream. I'm still working on that.
And do you envision doing, fuller scale symphony, that sort of thing?
Thanks to Aditi, pretty much, yes. She's been in contact with some professional orchestras, and I think that there's interest in it. It's something that all of us have to deal with. And I think there are a lot of people in the medical community who are musically talented. And so I think that if we can connect with those people, we can maybe make something beautiful happen.
Casey, you mentioned before your daughter Rose, and mentioned the Cure a Rose Foundation. Foundations, of course, are always trying to raise money and raise awareness. Talk a little bit about the work of the foundation, how things are going, and how you think this might help.
Yeah, well, the process of developing a genetic treatment is typically pulled out of an academic institution as a proof of concept drug. And so seeing that sort of academic incentives can sometimes be publishing and funding their labs, biotech incentives and pharma incentives are really what's the profit margin on a drug. And, as a parent, your incentive is to create a cure for your kid. So I wanted to be laser focused on that with the foundation. So we wanted to build a platform while we're building Rose's genetic treatment for her disease, that we could do this again and again and again in a faster, more efficient process. And so that's what we've done. We've raised enough money and we've created the first proof of concept drug for my daughter's disease, that exists anywhere in the world.
Wow.
The problem then becomes getting it into the FDA and the $2 to $4 million that it takes to do the required studies. Proof of concept drug is a lot cheaper to make than it is to do all the safety and GMP manufacturing it takes to actually get into a phase 1 trial. So, that's where I'm at with that. But I'm very excited about creating a pathway. So for the next parent, for the next Rose, for the next disease that we discover, can all the work that we do begin to create efficiencies and a larger path instead of continuing to just cut down, new trails and the learnings that happen in that, can we begin to sort of widen this path for more families and more patients and ultimately more cures?
Now, Aditi, you're a physician, but you're also working on a song yourself about a gene mutation that causes cerebral cavernous malformation. So tell us more about that.
Yeah. So around the time that I was having all these conversations with Stephen and Casey and then hearing about their experiences, I was also working with a group in New Mexico. And the New Mexico story is that in the late 1500s, there was a man from Spain who migrated to New Mexico, and he passed on this mutation known as CCM. cerebral cavernous malformations. And so typically it's a rare condition, but in New Mexico, there's a higher prevalence. And essentially I thought, okay, I heard the track that Casey had composed for his daughter. And it was very moving, and it's like emotionally riveting when I heard his track. And I said, could the same concept be applied, to a different condition where we have patients and families that can sort of drive this music? And so right now I'm working with a local musician and a community member who is personally affected by CCM, and they are penning the lyrics to the song. And it's like the genre is going to be more like Southern country, but the idea only came because I met Stephen and Casey. So just trying to transpose it to a different community and see how we can expand.
Wonderful. Yeah, once you get the creative juices flowing, it can go in any direction, right?
Mm-hmm.
We're almost out of time. Casey, I wanted to turn to you as a parent. We have a lot of learners, medical students, nursing students, and so forth, and also early career clinicians. What would you like them to understand about dealing with patients and family members who have rare diseases?
Yeah, I mean, that's a great question. We live in such an exciting time right now. If you look at the way, though, how education works, oftentimes you'll have a solution and it takes near a decade to get the training for this new solution. And science is moving so fast right now. And if there's one thing for early clinicians, or in their career, is genetic testing is so important. And even the idea of genetic testing for diseases that don't have current therapeutics, because those numbers give people the ability to showcase that this disease is an issue and brings in more resources. So I'm like, test everyone and test often, because new variants show up. So go back to the website the year later. If yours was a variant of unknown significance, go back a year later. It may change, but it opens up a pathway of hope and understanding to parents that don't know what's going on with their children. And I'd say the last thing is these parents are surviving. They're surviving day to day. And when you become a number because you've reached the dead end of your healthcare system, it is really depressing, And so I think from a clinician standpoint, nurse's standpoint, you have the ability to educate yourself on potential pathways that provide hope. And the parents are having to do that because no one else is right now. But I think in the future, we're going to see the medical community really rising to the occasion here, and so that's my encouragement. There's so much innovation that can be done, but we need leaders in every place of medicine, to have courage and have the bravery to believe that they can make an impact.
Well, we're almost out of time, but I do want to give each of you a chance to let people know how they can learn more about your fascinating work. Steve Taylor, where should people go for that?
You can find me at illinois.edu, which is for the University of Illinois at Urbana-Champaign, or I also have a website at stephenandrewtaylor.net.
And Aditi, for folks who want to keep track of all this, where should they go?
Probably the best way is for people to check out my LinkedIn.
And Casey McPherson, what about you?
You can follow my story at securerose.org, and then you can check out some of the music at alpharev.com and flyingcolorsmusic.com.
Well, listen, this has been as fascinating as I hoped it would be, and I want to thank you all so much, not only for spending time with us today, but for this really innovative and important work that you're doing.
Thanks, Michael.
Thanks a lot.
Thank you, Michael, for having us.
So as we wrap up here, let's listen to another selection of Steve Taylor's to give you a sense of the different kinds of music that he's producing from that. It's called Winged Helix Cardinal Whale, and it's a representation of the FOXP2 gene. I'm Michael Carrese. Thanks very much for checking out today's show. And as always, remember to do your part to raise the line and strengthen the healthcare system. We're all in this together.
If you like this podcast, please share it on your social channels. You can also subscribe to the series and check out all of our episodes at osmosis.org/raisethelines podcast.